What's up, you guys? So we are going to work on Roman to integer. So we're going to accept a string like I, and we're going to return the integer value. So in this case, 3, IV would return 4, and IX would return 9. And there's a few different edge cases that we have to account for, but for the most part, we'll be making conversions with this table here. Okay, and so here are the edge cases that we need to consider. Sometimes we need to subtract the value. So generally, we're going to be adding values to our so we're going to create a sum and then sum each character added to the sum, but sometimes we'll need to subtract. And so this describes the situations where we're going to subtract. So let's just start with a general outline of what we're going to be doing. So what are we going to do? For each Roman numeral, convert to int, add it to sum, and then we're going to return sum. That's all. That's like kind of like a very general. And so now let's think about how we can do this. How can we incorporate the edge cases? So if I comes before v, so IV is going to be 4, and IX is going to be 9 instead of like adding it. Okay, so we've got these edge cases. Let's just note them here. So edge cases. IV, IX, XL, XC, CD, and CM. So if we get one of those edge cases, we need to subtract whichever character we're currently on. So the question is, when are we going to subtract? We're going to subtract if it's an edge case, or is a subtract case. We'll call it is subtract case. Okay, so so how do we convert it to an int? We're going to say if is subtract case. We're going to give it the index and the string. If it's a subtract case, we want to subtract it from the sum. So sum minus equals what are we going to do here? Integer. We'll just call it integer for now. Else, we're going to add the integer. So we need to figure out like how is it a subtract case or not. So how do we do that? Let's think about that that function. Okay, so function is subtract case. Is subtract case. It's going to take an index, which is an int, and s, which is a string, and it's going to return a Boolean, true or false. Okay, so how are we going to do this? We can say val subtract cases okay, there we go. And so what are we going to do? If it's a subtract case, we're going to return true. Otherwise, we'll return false. So return if substring. So we have a index describes a certain point. So index will be either, in this example, 0, 1, or 2. So if we get 0, we want to know is II a subtract case. And so we would do s.substring from index to index plus 2 in subtract cases. Return true, else false. Okay, so we're going to be looking at all pairs of Roman numerals to see if they're one of our subtract cases. So that creates a weird situation. So let's think here. Okay, so if we start at the beginning, we take 0 and 1. Let's do this for example. And let's think about, like, are we going to traverse from beginning to end or end to beginning? So if we start at the beginning, we give index 0. It's going to find substring from 0 to 2, which is just II. So this second argument is exclusive. It doesn't include the last part of it. So it includes II. Okay. And then when we give it 1, it's going to be substring 1 to 3. And I believe that's going to give it's going to throw an exception because there is no 3 index here. There's only a 2 index. And so that's why starting at the beginning is not going to work. But if we start at the end, we start at this is s.length minus 2. So the indices here are, indices equal s.length minus 1, that's the last value, minus 2, and minus 3, down to 0. Okay. So if we start at, okay, so we're going to start here. Length minus 2, because that way we're always going to get a successful substring call. We're not going to get an exception when we call substring. Okay. So for 3, this would start at the second I, and it would end at the first I. And we would never get any exception. So that leaves the case, what about the last value, right? Like we skipped, if we start at second to last, we skip the first one. So we need to add, at the end, we need to add the last value. Last Roman as integer. Sorry. Okay. Yeah, we need to make sure we add the last one. Okay. And what's the space and time complexity of this? Okay, let's think about that. So this should be constant time that is subtract cases. And this is a loop that runs through the length of string. So O of n runtime, and space complexity, and let's think. O of 1 space, because we're just using this sum variable. O of 1 space complexity. I think that's right. Go ahead and drop me a comment if that's wrong, or if you have some other way of thinking about it. Okay, you guys, let's try and convert this to code here. Boom. I'll just start from the beginning. So we're going to do a variable, sum, set it to 0, and we're going to, like we talked about, we're going to start at the end. So we're going to do s.length minus 2 down to 0. And what are we going to do? If is subtract case, index string, we're going to subtract Roman, call it Roman s of index. Okay, and so what is Roman? So we need to make that's annoying. Sorry. I'm gonna change something real quick. Let's make this 4 spaces. Okay. All right, y'all. Okay, what is Roman? Roman is val Roman. It's a hash map of characters and ints. Oops. Okay, and it's going to contain our conversions here. Let's see if this works. Huh. And we're just going to not be lazy and just write this ourselves. Okay. Whoops. And we're going to do, because it's a character, we're going to do single quotes. So a double quote is recognized as a string. V 2 5. Let's just copy this. X is 10. L is 50. 50, 100, 1,000. Let's see. Okay. Yeah. Okay. So that's what Roman is. What else here? Else. We're going to add it. Okay. And then at the end, we need to return sum plus the last conversion, the last character converted to an integer. Okay. And now we need to make is subtract case. If you take a look at the discussion section and see how other people are solving this, they're doing it a little bit differently. They're just saying whenever you get, the solutions I saw were that whenever you get a value that is followed by a larger value, subtract that value. Like so here, they're only asking for IV and IX, right? So IV, IX. The solutions I saw and discussed were also doing this for IL, IC, ID, IM. And that makes the code a little bit simpler. So that's why I'm thinking they did that. I'm not really sure. But we're just going to follow the instructions here and use only these cases. Okay, so index is an int, s is a string. It's going to return a Boolean. And let's just copy what we got down here. That works. Let's see if this works. expecting an argument. Maybe that's this trailing comma. Let's try it. Uh-oh. What now? Oh, okay. Forgot in. Okay. Let's see if this works. Unresolved reference. Hash map of. Oh, I think I need to declare this like this. Is that right? Char int. So we're going to Google that. Declare hash map Kotlin. Okay. Huh. So here's how they're doing it here. Are we doing it the same way? So it looks like we don't need this part. That doesn't work? That's interesting. Oh, I see. I'm naming it wrong. Okay, what's the problem here? Type mismatch, infer type is int, but int was expected. Oh, right, so with Kotlin we need to, Kotlin thinks that like it's possible that s-index returns null. So if we call Roman null, like we're not gonna get any response here. So we need to say, all right, if this is ever null, even though we know it won't be, but it may, just give 0 instead. This is called the Elvis operator. So if this front portion is null, it will take 0 instead. And so I think we're going to have to do that every time we have this. So let's get in front of them here, and let's go like that, and click that in parentheses. Okay, let's see if this works. And that makes our code a little bit easier to debug because we're not going to get a null pointer exception. Oh, what's the answer? What's the problem here? Okay, so we got a debug and answer here. All right. We got 121. Oh, because we don't have 500 in there. Wait. D. We forgot D. D. Oops. Okay, so I think that should work. Let's see. Yeah, I just forgot to copy our D conversion to 500. Okay, let's try that. Okay, there you go, guys. So that passes. I believe this is O of n time and O of 1 complexity. Go ahead and let me know if you guys think that's something different there. But this is how to convert Roman numerals to integer values. All right, guys, see you next time.